University of, let's say, Utara, Institute Teknologi Sumatera. This is a very important uh, guest lecture, I think. As an environmental engineer, we can learn so many things from the geospatial technology side. As I have mentioned before, it is it is two aspects. One aspect, environmental issue, environmental problem, environmental engineering issue, and the other side is geospatial technology, remote sensing, GIS, maybe a drone as well, and how these tools, this technology can be used as our uh, tools to analyze, to collect data, analyze environmental issue. So yeah, if we can learn something from this, we can be mastered on this tool analysis. Yeah, it can sharpen our analysis to the environmental issue as well. So I hope you all, uh, especially our student, you can learn so many things here. You can learn the tools, the technical tools aspect. You can learn the uh, issues aspect, how where is the direction of the environmental issue right now, and how the international expert uh, has, what is it, has done uh, things, and how then this can be used for you, our student, to do something in your future, maybe in your research for your final final project or something like that. So yeah, we are very happy, and I hope this event, this international guest lecture, can runs well. No technical issue, no problem with the technical issue. Yeah, yeah, I'm very happy. Thank you so much.
All right, what a wonderful speech from Mr. Zaid Perdana Nasution. All right, next speech will be delivered from the Faculty of Infrastructural Technology and Regional Development from Institute Technology Sumatera. Please welcome Mr. Arif Roman, STMK.
Okay, thank you, India. Thank you for having me here to Dr. Zaid Nasution, yeah, our colleague and yeah, our senior here in the related field of the geography. So I was with him in University of Leeds in the UK. The difference is he has he had his PhD. I have not done yet. I'm still doing it. The Honorable Dr. Sarif Islam, yeah, we are pleased to have you here, but maybe next year or sometime we will have you in person in Indonesia, and we can gather in Usu or in Itera. We are in the opposite direction of the Sumatra, so in the north and the south.
Yeah.
We are in the south, right? And Mr. Zaid and Mr. Dr. Ade is in the north of the Sumatra. So you can pick. You can pick which area you want to visit, the north or the south. We will glad to have you next year maybe, or sometimes maybe Dr. Zaid we can arrange some seminar or international seminar with Dr. Sarif Islam as a keynote speaker or the invited speaker. So related to the topic, we are using geospatial technology to address global environmental issue. We have here the same as the USU, Dr. Adri. Uh, we have the environmental engineering also in ITERA. I think Mr. Anas is here as the head of the program, and the one that bring us together, Dr. Raden Putra. I hope he's in here also. So related to the environmental engineering, we have lots of things that we can explore in, especially in the Sumatra. Not not to mention all the Indonesian area. In the Sumatra, we have forest fire every year maybe, and we have flood, landslide, and yeah, we can also the social construction that maybe two 2 months later we will have the election all of the Indonesian, yeah, also the Sumatra. So maybe we will have some, we call it party, but it's not close to a party. The happiest party maybe the what is the closest word, uh, tegang itu apa? Menegah. Ya mungkin maybe we will have some friction or in social. So we need to model it in the spatial where that this social event will have the bad thing. Uh, so maybe something like that. And as the environmental engineering, we also sorry. Uh, sorry, I close it. As an environmental engineering, yeah, we also hope that we have a partner. So now we have USU. Maybe we can collaborate with other university along Sumatra to make some circle of the environmental engineering. And now we have Dr. Sarif Islam as the proxy is in America, maybe in MIT. So maybe we will have something different later, Dr. Zaid, for the Sumatra in the perspective of America, maybe. So that's the thing I would love to hear today. So maybe that's all. I hope we are enjoy this lovely morning in here. I don't know if that's the evening or what time is it in America now?
It's
Is it
nine.
nine? Oh,
9:30.
it's still
Yeah.
nine. I'm so
At
sorry.
9.
No,
Nine.
Yeah,
that's
yeah.
okay.
Yeah, nine. Okay. Yeah. So enjoy the guest lecture and thank you again.
Uh,
Assalamualaikum.
Waalaikumsalam. Can I ask, please, just one? Pak Arif, I think you are from the
Yeah.
geodetic engineering, right?
Yeah.
So
Yes.
yeah, Dr. Adri and Dr. Sharif, Pak Arif Rahman has his bachelor background from geodetic engineering, which means that he also has his expertise in geospatial engineering and geospatial technology as well. So yeah.
Yeah.
Beside as a dean, he also has expertise in geospatial engineering, geospatial technology. So I think this potential collaboration can have a good chance in the future. I think. Thank you.
Yeah. That I forgot to mention. Yeah. My my background is in geodesy. So yeah, this the geospatial analysis and this is the very interesting point for me to hear what what we have in USU and what we have in MIT. I think. Yeah. Yes, we will have the collaboration later, of course, Dr. Zai, of course. When you met us in Lampung.
Yep. Okay. Yeah. Thank you.
Let's continue. Thank you.
Thank you.
Cheers.
All right, thank you very much from Mr. Arif Rahman for the really wonderful speech. All right, the next activity is a presentation from the speaker and a discussion session, where the session will be guided by Mr. Dr. Adri Huda SSE. He graduated in bachelor degree from chemistry, Universitas Sumatera Utara, and his PhD from environmental science, Universitas Sriwijaya. His research areas are photocatalysts, wastewater treatment development, and material design with machine learning. Currently, he is an assistant professor in environmental engineering, Universitas Sumatera Utara, and he is the principal investigator in his research group, Energy and Advanced Materials Manufacturing. He had several local, national, and international working experience, including visiting scientists, postdoc, and research associate from Sumatera University in Sumatera, United States, Brazil, and Vietnam. Those are the CV from Mr. Dr. Adrihuda SSE. So for that, please kindly welcome our moderator, Mr. Dr. Adrihuda SSE.
Thank you so much, Elia, for a short introduction about me. First of all, thank you, Pak Zaid, for supporting this program, and also Pak Arif, who our collaborator. And in this session, I see that there is also Pak Raden Putra from ITERA, Institute Teknologi Sumatera. Welcome. Thank you so much for supporting this program and make this international guest lecture happen. I'm really happy that there's a lot of participants to join this meeting. So let me guide this lecture for, I think, an hour from now, related to how geospatial technology can address the global environmental issue. But before we move to the main agenda, let me give you a short introduction about our very nice speaker. Mr. Sharif Islam currently is a postdoctoral research associate in Media Lab at Massachusetts Institute of Technology in Massachusetts in United States. Dr. Islam graduated his bachelor degree from Environmental Science and Resource Management, Department of Environmental Science and Resource Management in Maulana Bashani Science and Technology University in Bangladesh, and he continued his master degree on Bangladesh University of Engineering and Technology in Dhaka with a special with the concentration on water resource development, Institute of Water and Flood Management, and then he continued to pursue the master on Kane State University in Kane, Ohio, in Department of Geography. And again, I think Dr. Sharif is really expert on geography and data analysis, and he continued his again master degree on Virginia Tech in data analysis and applied science, Department of Statistics, with a specific works on remote sensing. Correct me if I'm wrong, Dr. Islam. And Dr. Islam is also got the PhD from geospatial and environmental analysis from Department of Geography from Virginia Tech, with a dissertation topic is coastal erosion hazard in Bangladesh, space-time pattern analysis and empirical forecasting, impacts on land use, cover, and human risk perception. Dr. Sharif is has the several professional expertise, including the teaching assistant, associate collaborator, graduate research assistant, and now as postdoctoral research associate. He has a lot of publication. I could mention one of them, maybe in 2023, in a remote sensing journal, assessment of spatio-temporal variation of PM 2.5 and associate long-range air mass transport and mortality in South Asia. And Dr. Sharif also has a lot of publication, not only in journal, it's also in book chapter, and a lot of in under review in manuscript. And he teach a lot of courses, including physical geography, and then advanced interdisciplinary issue and ethics in water research. I think let's. I think if I should mention all of the award, the expertise of Dr. Sharif, maybe it takes maybe half an hour. So I think the main agenda is to hear the experience and the expertise of Dr. Sharif, especially related to how the geospatial technology could address the global environmental issue. Again, thank you so much, Dr. Sharif. I will guide this lecture. Please, everyone, welcome Dr. Sharif.
Thank you so much, Dr. Adrihuda. and it was generous, interaction. Like you talked about all the things that I did. So thank you for that. And I'm happy to be here and talk about my research, like my present research as well as my past research, as well as maybe at the end I'll be talking a little bit my journey from Bangladesh to the US, how I came and what are the things that I did, to come here to get scholarship kind of thing. So let me just share my screen before I start talking. Do you see my screen? Do you see my screen? Is that full screen?
Yeah, yeah, yeah. We can see.
Okay, so you are not seeing the next slide, right? Only one slide, right?
Yeah, it's only the main like that.
Okay, okay, that sounds good. Yeah, I just wanted to confirm that, you are not looking at the other slide as well. So, yeah, so hello everyone. My name is Sharif Islam, and I'm excited to be here actually. And I met Adri a long time ago, back in 2017, when we been to Germany to attend the summer school there. So after that, we've been friends, talked sometime. He came to the US, even though we could not meet, but we had this connection. So recently, he invited me to talk about my research as well as other how about my experience of how I came to the US and all this. So I'll be talking all these things. And today's presentation title is using geospatial technologies to address global environmental issues. So I'll be talking mostly about our work in Angola, where we're using satellite data to map soil moisture. So I'll be mostly talking about that, and also I'll be talking a little bit about the work that I did previously, part of my dissertation. Okay, so here's the outline of the talk. So I'll be talking a little bit about the background kind of thing, what kind of satellite data that we are using, as well as what kind of tools that we use here, as well as I'll be talking about the projects that I work on. So I'll be talking about my current project where we are assessing agricultural drought in Angola using satellite data. So I'll be talking about that mostly, and then I'll be touching a little bit my another two projects. So one project is related to how we are using satellite data to estimate methane gas emissions in Brazil. And then I'll be talking about my dissertation research, and that was focused on, so Adri already mentioned that I focused on coastal erosion in Bangladesh and how displacement and all these things happened because of coastal erosion. So I'll be talking a little bit about that. And then at the end, I will be talking about my journey to, from Bangladesh to the US, and what are the things I did to come here, and, telling, some of the solutions for the students. Uh, yeah, so as I mentioned, like, my work is kind of like interdisciplinary. I'm bringing, my expertise from different fields like, geography, environmental science, social science, water resources, data analysis and applied statistics, and remote sensing GIS stuff finally. So here in this slide, you can see, so these are different satellites. Those missions are NASA missions. So NASA is one of the main sources of data, that remote sensing data that we use. And you can see there are different missions though that are on the space right now taking pictures of the earth. So this is the earth fleet, and you can see there are different time frame, like when the different missions were started, and then showing some future missions as well. So if you look here, so this part is showing like in the future what are the missions that are coming up. And from my experience, I actually used multiple mission data. For example, I heavily use Landsat data, and Landsat has different missions like Landsat 5, 7, 8, 9, so different missions. So here is Landsat 8. I also used Aqua and Aura data for looking at air pollution kind of thing. So our work in agriculture where we're using this data is called SMAP, soil moisture active passive, how we are using that data to look at agricultural drought issue over there. So I'll be talking about that. I recently started working on a project where we are using signals data. So that is another NASA data that we are planning to use for looking at the drought, not drought, sorry, cyclone track in Mexico. So that is another sources of data that I use. So there is Landsat, there is other data set as well. So it's showing all the fleets that NASA has right now, as well as what are the future missions going to be. Before I go to my presentation, I would like to mention that the work that we do here at MIT, those are focused on these sustainable development goals. So you might have seen this, picture. So United Nations actually adopted this back in, I don't know, maybe 2012 or sometime in the 2000. I don't remember when it was, but so after Millennium Development Goal, they adopted Sustainable Development Goal. And here I mention like all the sustainable development goals they have, and our projects are focused on multiple issues. For example, like the work that I'm going to talk about in Angola. So that is part of this no hunger thing, because we are looking at agricultural drought, food production kind of thing. I will be talking about the other projects. So those are related to climate action as well as life on Earth. So I just wanted to show that our work is directly related to different SDGs. In this figure, I would like to mention that we use a framework, and it's called Environmental Vulnerability Decision Making and Technology Framework. So in small form, it's called EVDT framework. So when I say EVDT framework, it means that when we look at an environmental issue, we just don't look at the environmental model, just looking at doing model to look at the environmental aspect. We also bring data related to vulnerability, socioeconomic vulnerability. So I'll be talking a little bit about this too, mostly. And then we also bring knowledge about the decision-making process that are influencing this entire system. And then finally, we actually develop a decision support tool, part of this technology design model, which is useful for the future, for the decision makers, so that they can use that tool to have better decisions in terms of that particular environmental issues. So yeah, so as I mentioned, like the first thing I would like to talk about is our project in Angola, where we are looking at agricultural drought using this EVDT framework that I mentioned already. And before I talk about the project, I would like to mention that when I talk about drought, so there are different ways you can look at drought. But in this case, we are not addressing all types of drought, but the soil water deficiency. So how is the water content in the soil? So that is one of the ways how you can actually look at this agricultural drought issue. So there are other ways you can actually look at drought issues as well. And here are some background information. And we know that there are many countries, most of the countries in the world are actually vulnerable to climate change. And because of climate change, there are different things are going on. And Indonesia is another country, one of the most vulnerable country as well in terms of climate change in the world, right? And in terms of drought, so they are actually significantly impacted over the recent years. And according to World Bank, Angola is currently facing its most severe drought in the last 40 years. So recently they are having severe drought issue over there. And this crisis is directly affecting the food security of over 1.5 million people in the southern provinces of the country. And another thing is that, as I mentioned, southern provinces, so southern Angola faces recurring cycles of drought and flood. So it's not only about drought, so they also have severe flooding as well. And that causes insecurity for local communities who depend heavily on raising cattle as a form of livelihood. And then there is other things as well, agricultural production and other things are also impacted. And in this project, so one of the data that I already mentioned about the SMAP data. So in this project, we are using SMAP data, and the full form of SMAP is called soil moisture active passive. So, and using this data, we are actually we are measuring the water content in the soil. And you might not know, but I would like to mention that we are following a way of looking at this drought. So U.S. government has a drought monitoring system, and it's called U.S. Drought Monitor. If you just Google it, you will find it. And U.S. Drought Monitor actually uses 5 different categories to actually tell how is the water content in the soil by telling D0 to D4 drought. So D0 means abnormally drought and D4 means exceptional drought. So means that the dark red areas are most impacted by drought. So for Angola, we are using this same approach. So we are using this satellite data to develop this product with these categories D0 to D4 drought. In the coming slide, so in this slide, you can see how we are using SMAP data to actually assess the soil moisture content in the soil. So this image on the left are showing this image in the left showing the different depths of soil moisture content. So there is two terms. So one term is called surface soil moisture, and then the other thing is root zone soil moisture. So in this case, we are not looking at the surface soil moisture. Rather, we are looking at the root zone soil moisture. And the root zone soil moisture is like few centimeter under the soil. So deep soil kind of subsurface soil. So we are looking at that using this data, using different method called beta distribution feed and other things. We actually, estimated this D0 to D4 drought. And this figure on the right side is showing how every month this drought is changing. And you can see, as I mentioned already, the dark red areas are actually severely impacted by drought over time. And the white areas are not impacted by drought for that specific month. And so similar to the previous figure, when you were looking at how this drought is changing over time. So this one is showing how monthly drought is changing based on different categories, D0 to D4, just showing the time series kind of thing. And you can see in some months it was very extreme, but in some other months it was not that extreme. So it's pretty normal, but yeah. So we looked at this issue using data from 2015 to 2023. We could not actually go beyond 2015 because the mission actually started to collect the data starting from sometime in 2015. So that's why we could not go back, even before 2015, even though we wanted to look at, further. And in the coming slide, so this is another kind of like visual, like how, so this is the map of Angola, and it's showing how this, drought pattern is changing over time for every 8 days. So this is not for month. The previous graph was showing every month how it's changing, but this one is showing how every 8 days the soil moisture content is actually changing over time. And so in this figure, I would like to mention that we had this monthly observation of drought level. And using that one, we actually, estimated like how different, so this, polygons here, those are showing different municipalities in Angola. So they have more than 160 municipalities. And we wanted to see how different municipalities are impacted by drought, like, to look at the aggregated value kind of thing. So we are calling that drought severity index. And this index will eventually be used with this different socioeconomic data, for example, percentage of forest cover, or surface water, or population density, HIV positive, and there are other sources of data that we brought to look at the socioeconomic aspect as well, because the final goal is that we have this drought severity data, And then we have this socioeconomic vulnerability data so that we can combine these two together and see the integrated drought risk in Angola. And that was the main goal. So we brought this, remote sensing data as well as data from different sources to calculate the socioeconomic vulnerability as well at municipal level. And in this slide, so I would like to mention that in terms of estimating the socioeconomic vulnerability, we gathered 20 different socioeconomic variables, and those covers different aspects of vulnerability like exposure, sensitivity, adaptive capacity. So this is actually based on the recommendation provided by IPCC. So they suggested that if you want to look at vulnerability aspect, you need to consider these three different components: exposure, sensitivity, and adaptive capacity. So we made sure that the 20 different variables that we are using, those are capturing all these three things together. And after that, we had this, using these 20 different variables, we actually recategorized them into 6 different categories. So agriculture, physical, social, demographic, health, and economic. So agricultural variable might had like 4 different variables. Physical might have 3 or 4, something like that. So we categorized them into 6 different categories based on existing literature, like how other people are developing as socioeconomic vulnerability index at different countries in the world. So we just followed other literature to actually have them categorized into 6 different components. And using that 6 different components, we actually calculated the socioeconomic vulnerability index. And for that, we actually use the expert determined weighting for these 6 different categories. So when we been to the field visit in Angola, we talked with 7 different experts to actually determine weight for different components. So in our case, we had 6 different components. So these people actually, expert people, categorize them into different categories so that because all these categories are not similarly impacting, right? So based on the expert elicitation, we actually put the weight, and then finally we calculated the socioeconomic vulnerability index at municipal level for the country of Angola. And then finally, our goal was to actually develop a drought bivariate classifier. So this map is showing, so if you look here, so these dark areas are showing that these municipalities like this, these are most impacted by both vulnerability and drought severity. So this 6 different municipalities were rated very high in both categories, drought severity as well as socioeconomic vulnerability. And there are different categories as well, but we wanted to see, what are the municipalities where, both the drought severity is very high as well as the socioeconomic vulnerability was also very high, to see the integrated drought risk in municipalities in Angola. And now I would like to talk a little bit about the project that we have in Brazil, where we're using a data set called Greenhouse Gas Set. So there is a small company in Canada, and this project was funded by NASA. So they actually gave money to this company to give us the data, satellite data, to work on issue related to methane emission in the city of Rio de Janeiro, Brazil. So our goal was to, so they have 5 different landfills in Rio, and our goal was to look at how is the methane is being emitted from those landfills. And on the right side, if you look at this figure here, so this figure is showing there are different sources of data that you can use to actually observe methane emissions using satellite data. So the data that we use, I already mentioned about the greenhouse gas set. So that is the data that we use, not the NASA data, but NASA actually got the data and gave us that data. So that's why we got the data. Kind of, it's not freely available. So it's actually kind of paid. And the main goal of this project was to supplement Rio de Janeiro's greenhouse gas emissions inventory process. So they are already using some kind of method to actually, so those are not space observation kind of method, but they are using some kind of manual method to see how is the methane emission. So our goal was to supplement that. And then the other goals were to provide timely geolocated emissions data to enable more targeted interventions. and also to build capacity so that this methodology could be adopted by other cities in Brazil or even outside all over the world using the methodology recommended by the greenhouse gas protocol for community scale CPCs. And in this project, as I mentioned, like we use this greenhouse gas data to see how is the methane plume that are visible from the space. So they actually capture like if there is a methane plume over landfills. And we found that there are many methane plumes, and based on the methane plumes that we found, those based on that we actually calculated the emission rate. And you can see I mentioned Rio de Janeiro city is actually using some kind of method. Those are not remote sensing method, but they're calculating the emission rate, and that was like those are also pretty close to the data that we are using. So it was like pretty similar kind of thing. So in this case, like, this might be helpful for the city government to actually use this kind of, remote sensing data to actually see the methane emissions from landfills. The other project, very briefly, I will be talking about is related to coastal erosion. And so this map is showing, one of the largest delta located in South Asia. It's called Ganges Brahmaputra Meghna Delta, and it's located in multiple countries. So entire country of Nepal, big portion of India, small portion of China, little bit of Myanmar, and most part of Bangladesh as well, Bhutan as well. So those are part of this big delta. And because of this deltaic environment and sea level rise, coastal erosion is happening in this deltaic region in Bangladesh. So my dissertation research was focused on this issue that was funded by National Science Foundation in the US. And part of that we had to go to the field and do field work, as well as the main product we used was Landsat data that is provided by NASA, and it's open access data. So as I was showing all the NASA fleet, so those are open access. So if you need some kind of data like Landsat or whatever, SMAP or Cygnus or whatever, so everything is available for free other than the greenhouse gas set that I talked about. And I know that the coastal erosion problem is not only problem in Bangladesh. So all over the world, the coastal areas are impacted by coastal erosion, and it's the issue in Indonesia as well. So I know a little bit about that as well. And because of coastal erosion, so in this area, so many people are being displaced. So they are moving to other areas because of that. And one of the other issues is that most of the people living in the coastal areas are actually poor people, and because like they depend on agriculture and fisheries for their livelihood, so they don't have money to move to other places and build their new houses kind of thing. So when they lose their houses into the water, means they are losing everything. So they are being displaced and moving to other areas. So this is showing how this erosion is happening in that region. And it's actually one of the highest in the world, the erosion rate. So if you look at the dark red areas, so those are showing more than 300 meters of shoreline erosion every year. And because of this, so these rate are like one of the highest in the world. So we published a paper, and when we looked at the existing literature, like how is the erosion rate, in other parts of the world, and we found that, so these rates are pretty high, one of the highest in the world. And with that, so we are also using satellite data for other things. Because of the time issue, I'm not talking about those. I just wanted to show that glimpse that what are the things that we are looking at using satellite data. And now I would like to talk a little bit about how I came to US from Bangladesh as a student, and then what was the process and what are the options that you guys have as a student, undergrad student in Indonesia. So if you want to come to North America, especially in the US, so there are some things you will have to do. I'll be showing a little bit about that from my experience. And since your background is environmental engineering, maybe you have the options like, you can come to departments like environmental or ecological engineering. There is like so many civil and environmental engineering department where you can come as well. If your background is related to water resources or hydrology, so there might be some departments related to that. There is biological system engineering department as well. And then there are science departments like environmental science or geospatial science and geosciences. So those are also options as well. and then the combinations of above. So I've been to a program called Geospatial and Environmental Analysis. So that is basically combination of geospatial and environmental science. So I was in this program at Virginia Tech. So there are different departments where you can do similar, be enrolled in similar programs where this and that program is combination of two different fields like geospatial and environmental kind of. And then the question is, what are the admission requirements if you would like to, come here for grad studies, like, masters or PhDs? You will have to complete based on your interest. Like if you want to come to master's program, you will have to have a bachelor degree. And if you want to come to PhD program, sometimes you can come directly from your bachelor because engineering bachelor is accepted for PhD directly in the US because the structure is very different than UK or other countries because part of the PhD program you will have the chance to complete the masters as well. So based on your interest, you will have to complete at least bachelor, and then you will have to meet certain GPA requirement, and that is pretty easy. And that is actually out of four. I don't know about Indonesian system, but in the US and Bangladesh as well, we had this GPA out of four. So if that is out of four, you need to have three out of four in your undergrad to actually apply to some other places. And I would like to mention that GPA matters. So try to keep your GPA as high as possible. Like higher is always better. And then you will have to take either this test like TOEFL, IELTS, or Duolingo. So either one you will have to take and get certain score. And then in most of the case, maybe 90% of the case or 95% case, you will have to take GRE to get admission in the US. But there are some universities where those are exception, like you don't need to. So they are waiving GRE requirement kind of thing. And my suggestion, as I said, like higher is always better. So in this is, in case of your GPA or TOEFL or GRE, higher is always better. And there are other things also, like if you have like after your undergrad, like if you do some kind of job, maybe really relevant job kind of thing, so those will help as well. And then also if you can get some research experience with your this as a
Hello.
and then
I think we have some internet issues. Sorry. Hello.
yeah, can you hear me?
Yep. Yep. Yep.
So there are different funding types. So you can apply for this kind of things: so graduate teaching assistantship, graduate assistantship, graduate research assistantship. There are some fellowships and scholarships as well. And I also have seen some students are coming from other countries where they are getting funding from the government and then they are coming. So I don't know about Indonesian case. You might also have from the government, like you can apply for some scholarship there and then you get it and then come to other countries as well. I don't know exactly about that. And here are some FAQs. So you might have a question like, is GRE mandatory for getting admission and scholarship? I would say not for every university, but mostly like 95% of the universities where you will have to take GRE to get admission. And then the question is, do I need to take both IELTS or TOEFL? Answer is no, you should take only one. So either IELTS, TOEFL, or Duolingo. So that should work. And then the question is, how much GRE score should I get to receive scholarship? The answer is no cutoff. So there is no requirement that you will have to get like, out of 340, you need to get 320 or 310, but it's always higher is better. So try to do your best. Just like, money, like as much as you have, it's actually better. And then also the question is like, how much IELTS score do I need to manage scholarship? So in most of the case, if you have like, more than 6.5, like 6.5 at least, you should be covered. Or in TOEFL, like you will have to have at least 79. And again, the higher is always better. And if you are interested to stay here, you can actually apply for PR and all this. So there is job opportunities. So US market is huge and the salary is pretty good compared to Indonesia or Bangladesh. If you want to come here and stay working for some companies or industry. And then also, you will get that chance. So after you complete your degree, you will get 1 or 3 years to stay here to look for job and work in kind of thing. And processing your PR after your study. So PR means permanent residence, so green card. So you can apply for that yourself by paying, by recruiting some lawyer. And also, if you work for a company, in most of the case, they will actually handle that part. So you don't need to worry about it. And then after you get green card, it will take maybe another 5 months, 5 years, sorry, 5 years to get American citizenship. So if you are willing to come here and stay, you can actually do that. So there are so many people are doing that. And with that, I would like to, conclude my presentation. And I would love to, if there is a time, I would love to take some questions, and I'm happy to answer. And if you want to reach out to me, here is my email address, so you can actually use that, to email me if you have, any questions about my presentation, about my research, as well as higher study kind of thing. And this, barcode here is showing. So if you just scan that, you can find our lab's website, and you can learn about different
Ada
things
nggak
about.
bercelana bukan?
So this will take you to our lab's website, so you can learn about our work at MIT. So thank you very much for having me, and I'm happy to answer any questions you might have.
Okay, thank you so much, Sharif. It's really a nice presentation. Thank you for sharing with us, Bang Zaid, Pak Arif, and everyone. So I personally asked Sharif to give some share about how he end up in US. So that's why in the last 3 4 slides, so he share about how to be, I mean, like to pursue master or PhD in US, because I just because 90% of the participant today is a student. I really wish that Sharif can also motivate them to study in grade school. Okay, now we open for question and answer. So everyone who has the question, just open the mic and then you can ask directly to Sharif. Is there any question?
Or if you don't wanna ask directly, you can
Oh,
post your question on the chat as well. So
yeah.
that should be fine.
Jika ada yang mau tanya dalam bahasa Indonesia nggak apa-apa, nanti saya bantu translatekan jika ada yang ingin tanya. It's okay. So if you want to say in Indonesia, I will try my best to translate it to English. So maybe I could start from my side. Sorry if it's I'm not really geospatial people, so you share that you get the data in case of Angola from this the US cases, the data. Is it the data like a open source, or is it like available the data for in case of Indonesia, or is it only in Angola? US do some project in Angola, so you have the access to get the data from Angola. Is it like whole the world, the satellite could provide the data?
That's a
How
great
it works?
question.
Mhm.
Yeah, so I would like to clear that, most of the data set that I have shown, like other than the greenhouse gas set data, so all data set is available for global scale. Anywhere you want, you can actually work using that data, and those are freely available. If you just search SMAP data, you will find, so many data for all over the world. So it's not only for Angola or for the US, so it's for global. So you can even, if you have interest to look in, how drought is happening, for example, in Sumatra or some other, island in Indonesia, you can actually get data for that as well. It's the same thing that we got for Angola project, or any other project that we are doing. So most of the data set, like Landsat, I mentioned Landsat and some other missions. So those data set are global and it's freely available online. So if you just Google it, you will find the link, download it, and process.
Okay, so related to make sure that the data is, like in is let's say that the drought area, for example, in one area it's extremely high, and then should we do some, like how to say it, like confirmation to do some on-site checking, or how it works, like basically in go special studies.
Yeah, so that's a very good question. So one of the way that we validate our results, for example, in case of, how is the drought condition in Angola, we are actually comparing that with some kind of, on-field kind of measurement. to validate our result, right? So I mentioned about the field visit kind of thing. So we actually look at those aspects. And I mentioned about the other data set. For example, we use Landsat data to look at shoreline erosion kind of thing. So there are some existing method where you can actually compare with some other data set that you will get from remote sensing kind of products, like comparing Landsat with say Planet Labs data or Sentinel data or other sources of data. So there are some validation kind of process where you can actually compare these two things together. But in case of SMAP data, so the right way of validation is that we've been to field and took some field measurement kind of thing about the soil moisture content and then validated our results. And that is typical way to do this kind of validation as well. Going to the field, collecting data kind of thing.
Well, thank you so much for very nice answer. So, is there any question from the participant? Just raise your hand, or you can just open your mic and then ask directly to Sarif. Is there any question so far?
Uh, sorry, Mr. Ajay, can I ask some question?
Okay, there is like from Elia and also Pak Hafiz. Mungkin Elia first, Pak Hafiz. Is it okay, Pak Hafiz? Uh, okay, I think we could start from Elia first.
All right, thank you for the change, Mr. Ajay. First of all, I want to say
Sorry, Elia. I think you have
thank
some internet connection.
you
Yeah,
Elia,
to the
I could not
speaker.
actually hear you well.
Sorry,
Elia.
wait,
Sorry.
sorry, wait.
Okay, I
Yeah,
think you could repeat the question. There is some internet connection issues. Can you repeat your question, please? Oh, there is some freezing right now. Okay, I think while waiting, Elia, to fix the issues, I think we could move to Pak Hafiz. Pak Hafiz, hello, Pak Hafiz. Hello, Pak
Okay,
Hafiz.
okay. I
Hafiz.
can you hear my voice?
Yes, Pak Hafiz.
Yeah, thank you, Mr. Adri. I have I think two questions for Sharif. The first is what is the basic knowledge to run or to make this? I think uh, for example, if do I need for like for example uh, Python or something like that to analyze or something. What is the basic knowledge that we could prepare to make this happen? And then the second question is about the data accuracy or the modeling accuracy for this model. So these two questions. Thank you.
Thank
Yeah,
you, Pak
so
Hafiz.
those
Yeah.
are great questions. So the first question is that the tools that we mostly use, it's called Google Earth Engine. So it's a cloud computing platform provided by Google, and it's free for everyone. So you can sign up for that. If you just type Google Earth Engine, CEE, so you can find that tool. So it's a Java-based, coding platform where you can access all the data. Like I mentioned about SMAP data, I mentioned about Landsat data. So you can, get those data over there. So those are already deposited over there by Google, and you can use their cloud computing platform to analyze the data and get the results. So we use that tool, Google Earth Engine. And then when you saw like some beautiful figures that we created or I created, so those are mostly we created using a tool. So the one that I use, those are paid ArcGIS. I don't know if you guys use that in Indonesia. So those are paid. You need to pay them. I don't know how much, but there are alternatives as well. So there is a tool called QGIS. So you can actually use that as well. So that is open access. So you can learn that on YouTube or whatever. And those are open access. You don't need to pay. So those will be freely available to make beautiful maps. As you mentioned about Python on R kind of thing. So those are also like I mostly use R for different analysis, geospatial data analysis. but Python is also another platform where people actually do this kind of geospatial analysis as well. So you can use Python, you can use R, but in that case you need to download the data first, right, and then bring it to R or Python to process it. But if you use Google Earth Engine, you don't need to download any data. So those data is already there. You will just process online and then export the results of the analysis, right? So that is the best platform in terms of processing this kind of data set. And the second question was related to, can you please remind me the second question that you had?
The model validation.
Yeah, so
If
as I
the data
mentioned,
accuracy for
yeah, so there are two parts of the answer. So the first part is that when NASA is publishing the data, so that is already validated. So in their way, so they will not publish something that is just not usable, right? So because they are one of the most reputed kind of organization in the world. NASA is NASA, right? So when they are sharing the data, means those are already validated from their perspective. And then in our case, we also validate because we are not using the raw data, we are using the process data, right? So we are processing this, Landsat data or SMAP data to look at other things like soil moisture content or shoreline kind of erosion. And then, as I mentioned, when Adri was asking that question, how we are validating our results of soil moisture content in Angola. So we had some field visits over there. So we collected some ground truth kind of thing and then compared our results. So that is another way, like, so that is our part, like how we validate our results. But the product that is already published by NASA, those are also some kind of validated kind of thing. So two-step kind of process.
maybe I have one follow-up question. For example, can we make modeling for the small scale region, for example, in city scale or only country scale? What is the minimum scale that we can use this geospatial or satellite data?
It depends. So for
Uh,
example, I mentioned about Landsat data. So the resolution of Landsat data is 30 meter. So 30 square meter is the resolution. So 1 pixel is 30 square kilometer. And when I mention about the greenhouse gas set data, that is also 30 meter. But if I mention the SMAP data, so that is actually higher. It's like 11 kilometer is the 1 pixel. So if you would like to, look at the small scale, like a city, small city, I don't know, maybe Java or Sumatra, for example. So that will be like, covering only few pixels, right? Maybe 5 pixels, 10 pixels, right? So that is not best idea to use that data set. But if you would like to look at the global scale or maybe country scale kind of, so in that case, SMAP is fine. But for Landsat, in case of Landsat, if you would like to, so Landsat is being used for different applications. For example, if I would like to see how urban areas are being expanded, in a city like Sumatra or Java or Jakarta, so you can actually do that because the resolution is 30 meters. So the main point is it depends on the data sources that you are using. So some data might have 3 meter resolution, some might be 30 meters, some might be 1 kilometer or a few kilometers.
okay, thank you, Harry.
Thank you, Pak Hafiz. Thank you, sorry, for a question and answer. Is there any question from the participant or Elia? Can you ask the question? Are
Oh,
you online
yeah,
already?
yeah,
Please go ahead.
yeah, I'm ready. All right. First of all, thank you for the change, Mr. Dr. Agri. Um, I want to say thank you also. It's such a great experience to know such a pretty good materia. It's really cool. And to know it's actually from NASA, wow, this is really pretty cool, neat experience. All right. I wanna ask about as the student here. I wanna ask about the scholarship. What are the odds to beat up the scholarship in North America? And also about the fellowship. What's up with that? All
Elia,
right,
so
that would
was
be
your
my question.
question how is the odds of getting scholarship?
Yeah, what are the odds to getting the for getting the scholarship?
Okay. So the odds depend on the universities and your profile. For example, if you have very decent profile, for example, GPA, you have GPA of 4, and then you have some kind of like few publications, you have very good GRE score, very good TOEFL score, you can target top universities like MIT, Harvard, or Stanford. I don't know. I'm just saying randomly, right? And in these universities, in that case, maybe your profile will be competitive. But if you have a CGPA like 3.5, you have a mediocre GRE score or IELTS score, in that case, your chance is very low, right? Because in these universities, there are thousands of applicants are applying for few seats. Like say in a master's program or PhD program, there might be 20 or 15 different seats and 1,000 students applied from all over the world. So the odds are very low that you will get into MIT or Harvard, right? If you have a mediocre profile. But if you have very good profile and the university is top, like MIT, Harvard, you can find, like there is high chance that you will get funding or admission if you have very decent profile. But the strategy would be that, if you have mediocre profile, you will not apply to top universities. So you will be looking for, kind of medium level universities or low ranked universities, right? So they are like, I can tell you, like, they are very good. I'm not saying like, like low ranked universities are very bad because there is some standard, right? So in the US or, if you think about Canada or these developed countries, they have some kind of, threshold kind of thing. So they have minimum quality in terms of, the infrastructure and the facilities, resources kind of thing. But if you have a average kind of profile, my suggestion would be go for medium ranked or low ranked universities. So in that case, you will have higher chance to get the scholarship in those places. And I did not get your second part of the question. And if you can, repeat, I'm fine to answer. But I actually could not hear because of the internet connection issue.
So, like, if I could add, Sarif, the second question is related to: is it any opportunity to do some like internship, or in such a, for example, like in Media Lab or in NASA, that that can undergrad student can do, like spend one semester, 6 months there. Is it any either way? Like, is it like in case like we have some funding here in Indonesia, is it possible to do some, like training, or what is it? Yeah, internship, basically internship for 6 months to do some project there or help the project there. Is any have you heard about that?
Yeah, so there is two parts. So one part is it's possible. The other part is the issue of funding. So if you can bring, for example, you are the student who is, willing to come here to do internship kind of thing, and it's kind of self-funded. You are bringing the money to come here. In that case, it should be super easy. But if you don't have fund, in that case, it might be a little harder because you will have to convince some professors or, I don't know if NASA actually takes, interns from outside of the US. So that might be a regulation in the US. I don't know about their policies, but they might have. I don't know. But I'm just saying, if you don't have funding, in that case, it will be a little harder. You will have to either manage a professor or find some institute like NASA or other, industry or organization where they will give you fund to come here. So this semester, like, in our lab, there are multiple interns, undergrad interns, but they are US based students. But like, like one of the students, he's actually from Philippines. So he is doing his undergrad at Duke University in North Carolina, and he came as a funded student in our lab, worked with me in the Angola project. So he was working on that, and he is from Philippines, but he is studying in the US. Maybe that's why he got into, MIT, because he is already here. But I don't know about, outside students, for example, like students at USU, if that is a possibility. But there might be, but I don't know exactly if that is a possibility, kind of.
Okay, thank you so much, Sarif. A very nice
Mhm.
answer. Is there any question from the participants? Just raise your hand or maybe just open the mic and then you can ask the question. Is there any question? So is it's fine if you want to ask in Indonesia's, it's fine. I'll try my best to translate the question. Ya, jika ada yang mau tanya dalam bahasa Indonesia juga nggak masalah terkait ini, terkait beasiswa, terkait geospasial teknologi, nggak apa-apa. Nanti saya coba bantu translate. Ada yang mau ingin bertanya? Silakan. Roy Cassandra, you can open your mic.
Eh, Sebelumnya perkenalan diri, nama saya Muhammad Iqbal dari Teknik Geomatika ITERA. Saya ingin bertanya, tapi pakai bahasa Indonesia nggak apa-apa, Pak.
It should be fine. I will try my best to translate it to English. Sorry.
Eh, saya ingin bertanya untuk metode distribusi beta yang digunakan, apakah metode tersebut bisa digunakan untuk memperkirakan selain kelembaban tanah, seperti suhu tanah atau derajat keasaman tanah?
Ya, itu aja.
Ya, itu aja. Terima kasih.
So, Sharif, this is from ITERA. Jurusan apa tadi?
Teknik Geomatika.
Geomatics Engineering Department. So you show that you use the data to get the soil moisture, right? In case of Angola, and then with that data source, is it possible to calculate the other parameters, for example, like pH, the acidity, or the temperatures of the soil, or is it only for the moisture only uh, from the data source?
Yeah, so that's a very good question. And as I mentioned, the data name is called Soil Moisture Active Passive. So that mission is particularly designed to look at soil moisture. But if you have interest on water quality, my suggestion would be there are different sources of data that you can use. For example, Landsat data, people are using Landsat or Sentinel data to look at the water quality like BOD or COD kind of things. Not pH maybe, but turbidity and total dissolved solid and other things people are actually looking at using satellite data. If you just Google it, water quality and satellite data kind of thing, so you will find different literature. So there are different missions which data you can actually use to look at different water quality parameters, but
So
not
so
maybe the SNAP data.
So on that data source is only the moisture. So because the
Soil
moisture can,
moisture.
sometimes moisture can be, like correlated to maybe the temperatures of the soils.
Hmm?
Is it only soil? So do you have any like how can we access the data basically? Like, is it like just typing the US data soil, or how it works? Like, can you
Just
share
search like I can share if you
okay,
want. Okay, I
please?
can
It's
just
more
very
like
quickly share.
technically, like I'm really interested on it, to be honest.
Okay, okay. So let me just share very quickly. So app data download. There are different ways you can actually download this kind of data, but one of the source that I'll show you is the NASA data set. So let me just share my screen. Can you see my screen?
Yes.
So if you just search this one, this art data nasa.gov, you can find different data here. Right? Let me share in the chat as well. Can I share or no? I don't see a chat option, but if you can agree, like share the
It's okay.
link with the
Okay,
students. So yeah, so this is called artdata.nasa.gov. If you just click here on the find data, it will take you to different data set that there is. So there is API as well. So either way, you can actually do that. There is different other ways you can actually use. different platforms to actually get the data. So by topics, you can look at, for example, you would like to see the land surface. I'm just randomly going, I don't know, like if that is the right one. For example, soils, and then it will take you different. So is there soil moisture? So if you would like to see,
Yeah.
okay, so let me go back. So if you would like to see, as you mentioned, soil temperature, so there are data related to soil temperature as well. If you would like to see soil water holding capacity, you can click on that, or carbon or other things. So I'll be clicking on soil moisture thing, and then it will take me here. So this is the SMAP mission. And you see here, download SMAP data directly from here. So you can go here. You will have to open account and all this. But my main point is that if you just Google it, okay, I need to download SMAP data. So there should be different links. Use them to actually get the data. So when I clicked here, so it's showing me that data. You can just download it from here, kind of. So there are data set here. So that is a, so it's not like very hard. If you just Google it, like, I need this Landsat data or SMAP data or this data, that data. So that should be there.
Okay. Thank you so much, Roy. Dapat ya jawabannya ya. Mungkin bisa lihat ya di website yang diberikan. Gimana, Roy? Oke ya.
Baik, terima kasih.
Thank you, Sarif. Is there any more questions so far? We still have a couple more minutes before we end up this meeting. Sarif, excuse us for very late night here. I think it's already 10:30 p.m. I'm so sorry.
10:30 p.m.
Yeah.
No, that's okay.
Couple more minutes, maybe one more question before we end up this meeting. Is there any more question?
Excuse me, Sir Adri.
Okay, Danovan, please go ahead.
So, I want to ask one question actually. Does the geospatial technologies is capable of monitoring some water resources, and does this geospatial technologies is capable of solving the water scarcity issues? I think that. Thank you.
So maybe you could share a little bit about the water scarcity level, like cases maybe, Sarif, how we can use the geospatial technology to address the water scarcity based on your experience, maybe.
Yeah, so like I don't know if I can answer that question, because to me it seems like water scarcity is very broad topic, right?
Yeah.
So very broad, like drought is part of it, and then like drinking water scarcity, and there are other things as well. So my point is, like, I don't know how to answer that. But if you have a particular question, like, okay, I would like to see this water stress, or these kind of things, then might be I can come up with a question, not question answer, like how you can actually do that. And again, like my suggestion would be, I'm not expert of everything. Like, some of the things I look at using satellite data, but my suggestion would be, if you have some interest, like, okay, so I would like to see, like the hydrological drought or some other things. I will be Googling it, satellite data, hydrological drought, what kind of satellite data there might be, like, to address that issue. So you will find bunch of resources online. My suggestion would be that, like, Google it, like, use Google Scholar, to look for papers, or directly search on google.com, like what are the data set that is available to address that problem. So that would be my suggestion.
Ada pertanyaan lebih spesifik? Is there any specific question maybe Nanovan you want to ask?
Mungkin secara spesifik.
It's
Maybe
okay.
I don't have some. Maybe I don't have some specific question, but I just I have read some of the journals, and there is a there is some proof that the geospatial technologies thus can addressing some water scarcity issues. And I think I haven't understand some of the journal, and I think I need to hear some from the experts. Like,
Yeah, yeah. I think that's what Sharif said. That is, it's what talking about water scarcity is really broad. I mean, like it's really wide angle. So you could mention about the drought. You can mention about the supplies and everything. So I think you could contact Sharif if you have more question
Yeah,
and interested on it. And again, Sharif, I have tons of question on my WhatsApp already. Like, is it possible that we could share the presentation file, or is it like like it's in private, so I couldn't share it, or how it works,
you
like
can
basically?
share. It's fine. Just share.
Okay, I will share to the participant. Like maybe some of them want to directly connect with you, so that's why. Again, with the
Yeah.
limited time frame, so I think again in this opportunity, I would say thank you so much, Sharif. Very nice
No, thank
presentation,
you
very nice
for having
time.
me.
Hopefully, this is not the end. I mean, like the last one. I like Pak Arif, the dean already said that we really wish that to welcome you here in person in Indonesia. We will talk
I
later
would
after
love
this.
to.
We could arrange or plan some like program here, maybe like a summer school or technical training, like the one that we did in Germany before, like
Mhm.
hands-on to work on the geospatial technology. I will definitely contact you later after this program, and again, thank you so much for all the participants. If you have more question, we will send the files, the presentation file on the groups. We secretly have the WhatsApp group from this one. So yeah, I will share that one. And again, very highly appreciate for your time, Sharif. And to all the participants, thank you so much, Pak Zaid, Pak Arif, all of the professor faculty here, Pak Afizul. I couldn't mention all of people here. And thank you so much. This is the first international guest lecture. The program is managed by Environmental Engineering Department of Universitas Sumatera Utara. Hopefully, there is a second guest lecture, international guest lecture, maybe from Utara side, hopefully. And as a moderator, I'm so sorry if I make a mistake or maybe put the wrong translation to Sarif. And I think that's from my side. Thank you so much again. I will pass this room to the MC. Thank you.
Thank you.
Thank you so much, moderator. Now, with the end of the Q&A session from the participants, it was so intense. All right, our talk show also comes to an end. So before that, there will be a documentation session where participants are invited to activate their cameras. Please kindly turn on your camera so my friend Dwi Hidayah will take a screenshot per slide. Correctly, the time is yours.
So,
I will remind back to turn on all the cameras, the participants, so your faces will be on the screen. Thank you. Right, that is our documentation session.